Hello and welcome to this section 2.1 video today. Today we're starting our second unit here, and for the main part of this, we're talking about writing algebraic expressions, and a little bit with like what we consider to be verbal expressions, as well as algebraic expressions. So a couple things that I want to start with. And I'm just going to get a quick list. I'm not going to go through all of them. I'll focus on some other ones that we don't talk about here in class, because I think it's more important to get at least one idea and then move on from there. But what I want to look at here is ways to turn mathy writing into the English language, okay, in order to communicate our ideas and tell somebody else what we're trying to say, basically, because just to put us all on level playing field. So when I'm looking at this, I just want words that mean addition. Obviously, something like added to, and so for this kind of example, maybe I think of like 5 plus 7, right? Of course, I just said one. I could use the word plus. I could use 5 added to 7. I could use 5 plus 7. I could use the sum of, the sum of 5 and 7 would be a good way to do that. I think I'm going to stick to those three. There's a lot more. There's a bunch of different ways. But we'll see some more in some of the examples, as well as, like I said, I'll talk about some other ones in class. Subtraction. Okay, if I think of, let's flip it around a little bit so it's more positive, but 7 minus 5, right? I could say subtract, okay, well, I got to be able to spell things. But I can say subtracted. And there's kind of two ways to do that, because subtraction's a little bit weird in that the order that you write it matters, okay? So I'm going to actually include the 7 and the 5 here. 7 subtracted by 5, or I could also say 5 subtracted from 7. Right? Those are two different ways to use the word subtracted and come up with a valid response there. Another one I said minus. Minus is I consider it to be kind of a lazy way, but it definitely works. It gets your point across. 7 minus 5. A good one that's sort of similar to the sum of would be the difference of, or even the difference between. Now, it is important to remember that order matters in subtraction. And when I say the difference between, and then I'm going to list the two numbers, I want to make sure to say them in the order that I want them subtracted. So the difference between 7 and 5 would mean this. Okay, let's look at multiplication. Let's go, let's just think about 2 times 3. Okay, in multiplication, the order doesn't matter, so I'm not so worried about that. I might say multiplied by. I might say the lazy one times, or even the product of. So the product of 2 and 3. Okay, that's probably a good enough list for now. Division, let's go with something that kind of works out. Let's think about 10 divided by 2. And again, with division, just like subtraction, the order does matter. Okay, I don't want to say I don't want to say 2 divided by 10, right? Whereas over here, I could have said 3 multiplied by 2, and you'd get the same thing. It might not look the same, but you would get the same answer. So we might say the basic one, 10 divided by 2. There's no like quick way. That's kind of the quickest way. If you want to go with the item, kind of the last one that all the other ones have, it would be the quotient of. The quotient of 10 and 2. And there's not many other, I guess, good ones or ones that we can deal with very easily. Obviously you can say like 10 split into 2 equal groups, like that would do it. But that's just a little more work. Okay. All right, so now we want to put that into practice, and this is how we want to do this. So our goal here is to write an algebraic expression. So write something in math code, so to speak, that this problem describes. The product of, well, that's right here, and the product of means multiplication. So 5 and a number, who cares what the number is? Okay, since it's a number, let's call it n. So the product of 5 and n would be 5 times n. Or we could just write that 5n. A number, let's stick with n again, decreased by 72. Now remember, decreased by is probably going to lead us to thinking about subtraction. And since the order does matter, this one actually does a good job at giving us the order. Decreased by can replace, or the word decreased can always be substituted with subtracted. So in the subtracted by 72 would mean n minus 72. Okay. Next one, I have the difference of a number squared and 51. So we'll use n for a number again, but we do have an exponent q here. There's an exponent q, a number squared. Okay, and difference meant subtraction, so minus 51. Okay, now we've got some kind of involved problems, in that there's more than one thing happening. This one says the product of 15 and the sum of a number and 3. So again, I'm going to use n for my number. And I know that I want to take 15 times the sum of a number and 3. So that's the sum, means addition, and n and 3. Now, the trick here is the way this is written. If I follow order of operations here, it's going to say to multiply and then to add. But this kind of hides in there that we want to find this sum first. So there are parentheses around this based on how that was written. Whereas another way that you could say this, and this is where we always kind of come into some troubles, you could say, another way that you could write this would be like 15 times n plus 3. Now, the problem is when you write that, that looks the very same. Notice I paused in there, and then I kind of sped up a little bit. That would be the same as saying, or as writing 15 times n plus 3, which would mean something totally different saying it that way. Saying it that way would almost make me think 15 times n plus 3, right? Where I would follow order of operations, and there are no parentheses there. But this one is wrong, okay? The way this is written, it's saying the product of 15 and that sum. So, and the sum gives me these parentheses first. Another way to cue in parentheses that is pretty common is to say the quantity of, meaning you're going to figure out that quantity first and then do something else with it. Okay, but that's involved, but that's okay. The next one here, the quotient of quadruple a number and 12. So quotient means division. A number, let's use n again. What's quadruple? Well, quadruple is times 4. And 12 is obviously 12. Now, they kind of have some unwritten parentheses in here. We want to find quadruple a number and then find its quotient with that number in 12. So a couple ways we can write it. We can say 4n divided by 12, or it would be perfectly fine to use a fraction layout. And keep in mind what we talked about last week. This sets up a hidden set of parentheses right here. So that would be okay too. All right. Here we have a number added to 23, split into 3 equal groups. Okay, let's kind of make some notes here. So we have a number added to 23, and then somehow this means to split that into 3 equal groups or divide by 3. Okay, that's everything that's going to be happening in this problem, but the order does matter. The way we say this makes me think, well, okay, this one's pretty ambiguous. This one could be taken either way. Okay, we could either say that this is n plus 23 divided by 3, which is the original way that I read it. But that might not be right, because this could really say n plus 23 divided by 3. And then based on order of operations, these parentheses are actually not needed. Okay? And it's really in how you read it or how it's said. Like if somebody said a number added to 23 and then they paused and then they said, then split that into 3 equal groups, that would mean this top one. But if they said a number added to, and then they kind of paused, 23 split into 3 equal groups, then I would think this one. But it's all different when it's verbal, okay? And this one, yeah, this one's very ambiguous. You could take that either way. Let's turn the page and move on. So when we flip the script, I want to take an algebraic expression and turn it into what we consider to be a verbal or even written expression. So we want to do the same thing backwards. Now, when we're doing it this way, we definitely want to make it obvious what the order that we want these done in. Okay, if we want to change the order of operations, we need to note that. So I'm not the biggest fan of using the lazy ways all the time, but that does give us a correct answer. If I were to look at this one and if I were to read it in class, now I read it in class one way because it's quicker and we're all looking at it. Okay, but I have to pretend that the person I'm reading this to does not see it. Okay, so if I read this in class, this first one, I would say 10x plus 13. That's a very lazy way to say it. But it's also pretty universal in that everybody should understand it. And sure, you could elevate that to say 10 times x plus 13. But that's a little, that's still a little bit on the lazy side. So I want you to push yourself to come up with maybe a way you wouldn't think about it. Okay, I'm going to start this one by queuing in the addition. So I'm going to say that it's the sum of ten times a number So that's one piece that we're summing together or adding together. The other piece is 13, right? That's not too bad. And if I can ever get away from just saying 10 times a number, that would be good too. But I don't really think that I'd add in like the sum of, the product of 10 and a number and 13. Like, there's a little bit too much going on there. So I like that creativity, but it's just a little overkill. Okay. What's a good way to say 1/2 times x? I would think a good way to say that would be like half a number. So maybe I use the difference of, because this is subtraction. The difference of half a number and 5. Okay, that's a pretty good way to say it. And I use these ones quite a bit, right? Even on this next one, I would say the sum of, well, let's be more creative. I would typically say that, but let's try to be more creative. And it might even be quicker in our more creativity here. Let's say that we have a number squared. That means raising to the second power. Added to 15. That's not a bad answer. Okay, next one, we've got a couple things going on. So we've got multiplication to talk about. We've got raising to the third power. And you could say, for any exponent, you could say raised to whatever power. But I use squared because it's less writing. Okay, and a little bit more intuitive. And I've got subtraction going on. Okay, so this one I'm probably going to use the difference of to cue in the correct order of operations that I want to follow, even though it's the standard order of operations. So the difference of, let's get that first piece in there. Maybe we go with quadruple a number, since we saw that one already. Quadruple a number. Maybe a number cubed to get that exponent. And 72. But even with this could be taken the wrong way. Somebody could think that you want quadruple a number cubed when we really want quadruple a number cubed. See, there's a slight difference there, but it is important. If somebody thought you wanted quadruple a number cubed, they might think, okay, well, that's like 4x. And then in parentheses, and then I want to cube that whole result. Okay, so there's a little bit of issues there, but I'm okay with that. Okay, these last two, we need to change the order of operations. Okay, we need to cue in some parentheses. So as I said, there are some standard ways to do this. The first way is maybe I go more on the quicker path, because this is what we would usually say in class. We might say the quantity of a number, added to 7, and then I might even build in the pause with a comma there, and then I would want to say that I want to take that quantity and divide. I'm going to say divided by 10. Okay, that's a pretty good way to say that, and that's a pretty standard way to say that if you're just answering in class, right? We have to have ways to say these, but we also have to pretend that the other person can't see it. All right, next one, or last one, I guess. That's exciting. I've got a set of parentheses that I got to cue in, but I also have multiplication here, I have multiplication here, and I have subtraction here. So I've got to bring all those things into play. And so maybe say the product of, to talk about this outside multiplication, And now I don't want to say the product of again. So I am going to go a little bit quicker and just go with 15 times a number. Sorry, back up. The product of 7 and now I want to call in these parentheses, because if I just say 15 times a number minus 3, that could have the same effect of we don't know that those parentheses are involved. So I'm going to say the quantity 15 times a number added to, oh wow, or not. Let's use subtracted. But if I want to know that the 15 times the number comes first, I need to say subtracted by. So subtracted by 3. All right, and that'll be it for today. Trying to keep times down a little bit and get this out as soon as I can. So have a good day. Make sure you write any questions you have on the side, and we'll see you in class.